Independent and dependent events. So this is another one of my favorite sections because when you're calculating probability, it's just another thing that you can apply to real events, you can apply to the real world. So independent events would be that if the outcome of one event does not affect the outcome of another event, or vice versa, the events are independent. So examples would be like the choice of a sandwich and a drink, or choosing an ace, replacing it, and choosing a king, or a die is rolled and then the coin is tossed. Those things are not going to affect each other. So our notation, and looking over here, so this is the notation, would be that you just multiply those two probabilities together to get the overall probability. And so the probability of A and B would be the probability of A times the probability of B. So let's do some examples. So what is the probability of rolling a 5 on a 6-sided die followed by rolling an even number? So the probability of rolling a 5, well, there's only one 5 on a die, so that would be 1 6, 1 out of 6, and rolling an even number. Well, there are 3 even numbers. You got 2, 4, and 6, so that would be 3 out of 6. So you would multiply those. So you can either multiply it by hand or you can use your calculator, which is what I would suggest. Use your calculator, and then if you hit the math button, if you multiply your two fractions, you just use the division key to get a fraction, and then hit the math key, or you can do it on Desmos as well and reduce, and you will get 1/12. All right, using a standard deck of playing cards, so you can refer back to your previous notes if you don't know what a standard deck of playing cards consists of. Find the probability of selecting a spade, replacing it, and selecting a face card. So a spade is just a fourth of the deck because you have 4 suits. So that's going to be 1/4. And a face card. So face cards would be jacks, queens, and kings. So that's going to be 12 out of 52. So once again, you just multiply those, reduce your fraction. You'll get 3 out of 52 for your answer. Okay, so according to the U.S. Department of Transportation, the top 10 airlines in the U.S. arrive on time 80% of the time. During their vacation, the Hiroshi family has a direct flight to D.C., Seattle, and San Francisco on different days. What's the probability that all their flights arrive on time? So they have 3 flights, and each of them is 80%. So you would just multiply that 80% 3 times. Change it to a decimal, so we have 0.8 times 0.8 times 0.8, which would be 0.512. If we want to change that to a percent, it would be 51.2%. Okay, then we get to dependent events. So dependent events would be like dealing a deck of cards, because once cards are gone, that's going to affect what cards you have, whether you're playing poker or Uno or Phase 10. So choosing an ace followed by another ace, or drawing 3 marbles from a jar without replacement. So for our notation over here, so looking over here, if 2 events A and B are dependent, then the probability of both events occurring is the probability of A and B equals the probability of A times the probability of B following A. So we cannot just multiply the 2 probabilities because one affects the other. The second probability must be adjusted. So a card is chosen at random from a deck of cards and is not replaced, and a second card is chosen from the same deck. What's the probability both cards will be 7s? Okay, so first of all, there's 4 7s in a deck of cards. So the probability that our first card is 4 out of 52. Well, assuming that first card is, we always assume that we get that first 7. So anytime that you're doing probabilities like this, you always assume that first card picked is like what it's talking about. So assuming that first card is a 7, one of those 7s is now gone. So now you're down to 3. You have one less card in the deck now, so now you're down to 51 cards. And so now our probability, you just multiply your two fractions and reduce it. You'll get 1 out of 221. All right, what's the probability you were dealt a jack followed by an ace without replacing the first card? Well, there's 4 jacks in a deck of cards, 52 total cards. Now, we're doing an ace, okay? So none of the aces are gone. All your aces are still there, but you still have 1 less card in the deck. So we're down to 51 cards. So we multiply these two fractions and we get 4 out of 663. So that's our fraction. And we can turn these into decimals or we can leave them as fractions. Either way, just look and see what type of question, how they want you to answer it. Charlie has a bag that contains 4 red, 6 green, 3 purple candies. All right, so your total here, so 4 and 6 is 10, 3 is 13. So your total, you just might want to make yourself a note, your total is 13. He randomly chooses 3 candies, one after the other without replacing. What's the probability that he would choose all green? Okay, so if he has 6 green, if we pick the first green one, 6 out of 13. And then if he picks another green one, he's down to 5 out of 12 because one of those is gone. And then if he picks 4, because if one of those is gone, now he's down to 4 out of 11. We just multiply those three fractions and reduce that fraction. We get 10 out of 143. Okay, so determine the probability of selecting 2 navy socks one at a time from a drawer that contains 6 black and 4 navy. Okay, so our total here is 10. So if we're going to pick 2 navy socks, probability randomly selecting 2 navy socks one at a time, that contains 6 black and 4 navy. We have 4 total navy socks. So 4 out of 10 times 3 out of 9. Because this is our first sock. So here was like our first sock. Here is our second sock. We multiply those and we'll get 2 out of 15 for our total probability. So two-way tables, being able to read a two-way table, the most important thing, you've got to fill in your total. And most of the time, they're not going to give you, unfortunately, they're not going to give you these columns here, okay? If it's on like a ACT or SAT or even a state test, which we don't have this year in 2020. It may change in years to come if you're listening to these notes. But this current year in which these notes are made, we don't have it. But it may change. So I've got it on here for notes to make it easy, honest, to fill in. But you've got to have your total column because you can't calculate anything. So when you see a two-way table, you need to fill in your totals, okay? So that's the first thing that we're going to do here, okay? So let me get rid of these marks here, okay? So we're going to fill in our totals, okay? So you just go across, you add everything up. So our totals here are going to be these numbers. Okay, so suppose we randomly select one student. What is the probability that the student walked to school? So if they are walking to school, then we are looking at this total here. So 88 out of our grand total. So 88 out of 500, and of course we want to reduce that. So 22 out of 125. Okay, so that was a pretty easy one. All right. The probability of a 9th or a 10th grader, okay, so that total here, we're just looking at the 210. So 210 out of 500, and that's going to reduce to 21 over 50. So that was a pretty easy one. Okay, so our next one, probability that they rode the bus or 11th or a 12th grader. Okay, so Probability that they rode the bus. So we're looking here. Or 11th or 12th grader. Now, there is some overlap here, if you notice, okay? So, probability that they rode the bus is 147. Probability that they're an 11th or 12th grader is 290, okay? Now, obviously, there's an overlap. That overlap is 41. That means we are counting 41 of those students twice. So, we need to subtract 41 from that total. And if you remember back, that was in our addition formula. We learned that formula. That's part of our addition formula, okay? So that's why we're subtracting here. So that's going to give us a total of 396. And, of course, we still need to do that out of 500. And that's going to reduce to 99 out of 125. So that's going to be our final answer, okay? Okay, so now we get into one that looks like this. Probability they're an 11th or 12th grader given, this is the given symbol, given that they are a car rider. Okay, so let me get rid of these circles here. All right, let me fill my totals back in. That was 147, 210, and 290. Okay, so given that you're a car rider, that means you go to the car rider column. You kind of look at what's last. It's kind of like you start with your end and you work your way. That means you were looking here, okay, and then 11th or 12th grader. So it's 184 out of 254, okay? And then we're going to reduce that, 92 out of 127, okay? All right, so we'll do the same thing for the next one. So this is it's got the given here. So 9th or 10th grader. So that means you're kind of focusing on this row here. That means that your bottom number is going to be 210. So we're looking at the Walker portion. So 30 out of 210, and then that's going to reduce to 1/7. Okay, so that's how to read a two-way table. All right, so we'll do another example. Now, this one, I've already got the table set up for you. But this one, they give you information. They don't even give you a table, so you have to fill in the two-way table. So the manager of an ice cream shop is curious as to which customers are buying flavors of ice cream. He decides to track whether the customer is an adult or a child, I should say or, and whether they order vanilla or chocolate. He finds that 224 of his 224 customers in 1 week. So that right there tells us our total is 224. 146 ordered chocolate. So our total for chocolate is 146. He also finds that 52 of his 93 adult customers, so we know that we have a total of 93 adult customers, and that 52 of them ordered vanilla. Okay? Build a two-way table that tracks the type of customer and the ice cream. So then we can kind of fill in, based on what we know, we can fill in everything else, okay? So if I start, and I'm going to kind of switch colors here. If I start, I can fill in chocolate next in the adult, because I can do 93 minus 52, which is going to give me 41, all right? And then I can also do 224 minus 146 to give me 78. I can do my 78 minus 52 to give me 26. I can do 146 minus 41 here to give me 105. And then I can do lots of ways to get this last number here. I can do 224 minus 93 to give me 131. Or I can add up 26 and 105 to give me 131. Okay, so this is similar. We're going to focus more on kind of like the given problems, where it's got the given here. So given that it's an adult. So what that means here is that we're focusing, oops, I'm going to do my highlighter. given that it's an adult. Okay, so that means that my bottom number is 93. Given that it's an adult, we look at the vanilla. So 52 goes on top. And actually, that is completely reduced. So that's my answer. Okay. All right. So then if I switch gears here, probability that it's a child given that it's chocolate. So given that it's chocolate, I'm focusing on this one. I'm going to do my highlighter again. So I'm focusing on this. So my bottom number is 146. So then I look at the child intersection in that. So 105. 105 out of 46. Okay. And then last problem, I'm actually going to do a Venn diagram for this one. A survey asked students which type of music they listen to. Out of 200 students, 75 indicated pop music and 45 indicated country, with 22 of these students indicated they listen to both. So if I do a Venn diagram, I've got pop and I've got country, and it tells me 22 listen to both. So I know I've got 22 in the overlap here, okay? So it tells me that 75 listen to pop music. Well, 75 minus 22 is going to be 53. And then 45 listens to country. So if I do 45 minus 22, that's going to be 23, okay? And my total here that I have, if I add up what I have in these circles, if I do 55 plus 22 plus 23, I've got 100 here. That means basically 100 people didn't, oh wait, sorry, I typed in something wrong. 53 plus 22 plus 23, that gives me 98 in my circles. So that basically means that 102 people like something different, okay? So there's 102 people that indicated something different. So use a Venn diagram to find the probability that a randomly selected student listens to pop music given they listen to country. So given that they listen to country, that's going to be out of 45. And of course, 22 because of the intersection there. And then we just divide 22 out of 45. Or we'll see if that can be reduced. 22 out of 45. We'll double check that. I don't think it can be. And it can't. So actually, that is my final answer for that.